mentioned, I'm Jerry. I'm currently a senior at Lexington High School, and all of the other members on this team who put this chatbot together are also from Lexington High School. So let's go ahead and get into this presentation. So the things that I want to get through today, first, I'll be going over our team and the organization that we're a part of, which is called the Youth Team Initiative. And then I'll go into a brief overview of what the timeline was for this project in order to get this chatbot working. And then I'll be going over some of the system architecture as well as the setup for the chatbot. And then I'll go over some specific implementation details with code snippets. And then at the end, I'll leave time for questions from you guys as well.
Do you mind if we interrupt with questions if they're
yeah, sure. Yeah, that's fine too.
John, I'm going to suggest that maybe we don't. Yeah, let's take the questions at the end because I think everybody'd like to find out about the whole project within the time frame, and then we can worry about how much time we have for questions afterwards. And if we have so many questions, I'll invite Jerry back again.
All right. So first, to kind of introduce our team. So we're part of the organization called the Youth Team Initiative. And this is a community service organization that's based within Lexington. And our goal is to kind of design programmatic and other technological solutions to different sort of social problems that we see around town and in the greater Boston area. And 9 students from this organization were involved in working on developing this chatbot. And we actually have 2 versions of this chatbot, which you can see on this timeline here. So this project began back in December of 2023 as a collaboration with the Lex Observer. And originally the plan was to design a chatbot that could answer questions about Lexington's municipal budget in general. So in December of 2023, we had our first meeting with the Lex Observer, and we got introduced to some of our mentors from the Observer who would be working with us. And over the course of the next couple of months, we would begin prototyping different ideas for the chatbot. And our first design was finished around March of 2024. And that just so happened to be around the time of the annual town meeting. So we got to invite some of the town meeting members there to test out our products and then give us some feedback on what they thought and what could be improved. And so after the annual town meeting, we spent a couple months redesigning the chatbot to improve a couple of the features. And I'll be going over what improvements we made in this presentation. Late into 2024, a select few members from the chatbot team actually conducted some research on our framework for our chatbot and how that can generalize to other sort of domain-specific chatbots. And so we wrote up a research paper, and that was presented and published in 2024 as part of the IEEE Big Data Conference. And then in March of 2025, we began to specialize our project for the new Lexington High School project, because that's one of the really big topics in town. So we designed a specific version of our original chatbots that was focused on answering questions about the new Lexington High School project. And so in October, we released our final version of the LHS chatbot to the public, giving residents, 1.5 to 2 months to play around with it and learn as much as they can before the special debt exclusion vote took place on December 8th. That's kind of like a brief overview of the timeline. Now to get into some of the technical details. So first, the overall framework for our LLM system is called GRASP. And this was an acronym that we came up with. And the acronym stands for Generation with Retrieval and Action System for Prompts. And this acronym is kind of encompassing 2 of the main ideas that we incorporated into our framework. So first, generation with retrieval. So the G and the R in the acronym, this is referring to the RAG system. So RAG is an LLM system that stands for Retrieval Augmented Generation. And the idea behind RAG is that if you take an LLM, RAG allows you to supply external documents to the LLM, and it will be able to pull both from its internal training data as well as the new documents that you supply to answer the user. So essentially, if you don't want to have to train a new LLM with whatever new information you want, RAG provides you with a method to supply external documents that the LLM can utilize. And then the ASP part of the acronym stands for Action System for Prompts. And this is referring to another component of our LLM framework, which is React. So React is another common framework used for large language models, and it stands for reasoning and acting. So React, and essentially, this is kind of like a thinking framework for large language models. So it enables large language models to process user queries in a more complex manner. And if you look here in the figure, you can see that the way that React works is it processes user queries in three steps. There's thought, action, and observation. So first in the thought step, it's going to analyze the user query and decompose that into specific subgoals that it can take actions upon. And then in the action step, the agent or large language model will use different tools to complete those subgoals. And so in our case, let's take the Lexington budget chatbot, for example. We have one tool that's used for specifically the school budget sector and all of the information related to that, because that's like a really, really big part of the town's appropriations and stuff. And then we have a separate tool for all the stuff that's not school related, so more of like the general budget information. So essentially, in the action step, the agent can pick different tools based on what information it wants. So if the user is asking something about school budget, it'll use that school budget tool. And if it's asking questions about the general Lexington budget, then it'll use that tool. And one great thing about the React framework is that you can design all different kinds of tools that you want your agent to use. So for example, you can also design tools that allow your chatbot to make graphs or draw charts. Or you could have a tool that allows your chatbot to access some sort of online calculator. So by using web APIs, you can supply your large language model with all sorts of different online tools. But in our case, we just have two tools, one for the school budget and one for everything else. And these essentially contain different document sets that the chatbot has access to. And so after the chatbot has utilized these different tools in the action step and received different sorts of information, they proceed to the observation step, which is pretty much analyzing whatever information they received during the action step. So in our case, that would mean they pulled some information from the documents that they think is relevant to the user's query. And now they can analyze that, determine, okay, is this information what I need to answer the user or not? And then if it does think it's enough, it can, write out the response to the user. But another thing it can do is the React framework enables the LLM to kind of repeat this process over and over again to fetch more and more information, as long as it determines that it doesn't have enough to answer the user. So it'll kind of repeat this cycle of going through thought, action, and observation until it collects enough information where it feels like it's ready to answer the user. So again, just to summarize this slide, the GRASS framework is covering two of the major components of our chatbot, which is RAG, allows us to supply the LLM with external documents. So in our case, this would be the Lexington official documents. And then React is more of like a processing framework for how the chatbot is going to process user queries. So to discuss kind of the pros and cons of this framework, I think the pros here I've already kind of covered a little bit, but one of the big upsides of using React is that we're able to process queries multiple times. It's not just we prompt the LLM once and you get one response back. We can repeat this thought, action, observation cycle multiple times. And that allows the chatbot to be more accurate and more refined in its response. It's probably going to be more comprehensive and utilize a wider variety of information. So that's one of the big upsides. And so combining the RAG framework, which allows us to supply that Lexington-specific information, with the React framework that allows the chatbot to think about things a little more deeply, results in answers that are more likely to be grounded in the true documents as well as more accurate. So for some of the cons that I'll discuss here, the first thing is because the LLM is being prompted multiple times in order to answer the user, that may result in slower performance because you're causing the LLM to process things multiple times. In our case, we found that the responses still came back fairly quickly. So within just like a couple of seconds, you would usually get a response back. So this slower performance wasn't really something that we found to be a major issue. And then another thing is that because you're calling all of these different tools in order to fetch your information or do sorts of different things, that might cause some overhead. but again, we found that this wasn't really a big issue. So really the considerations when you're using this framework are you have to consider the trade-off between the time it takes for the query to come back and how accurate and comprehensive you want your response to be. And in our case, we found that using this combined framework was something that was really valuable to us, especially since when you're discussing civic topics, you want to make sure that you're as accurate as possible.
Can you quantify that?
Um,
John, we can talk about that.
Yeah,
afterwards,
I'll
please.
discuss this like a little bit later into the presentation. It's closer towards the end about how we evaluated and stuff like that. But first, I'll be going over some of the technical details. So now I'll be going over how RAG works. So as I mentioned, RAG essentially is supplying external documents to the large language model, and the large language model can subsequently use that information in its responses. And one of the main parts of RAG is you have to determine what part of the document you want to use based on each user query, right? And the way this works is by using vectors. So the first step in the process of using RAG is you have to convert all of these textual documents into numerical vector embeddings. And there are different models that can do this. So the model that we use is from OpenAI that allows you to convert text into vectors. And we can collect all of the vectors from the different documents that we have and store that into a vector database. And the reason why we want to do this is because it's much easier to compare things numerically than to compare things textually. So really what this embedding model is doing is it's storing that textual information into numbers. And these numbers semantically represent whatever text was originally there in the documents. And then the way that we can determine what information is relevant to the user and what information is not is by implementing something called vector similarity search. And so the way this works is that we have this vector database that contains a bunch of vectors representing different textual information. And then when the user passes in their query will also be converted into a vector. And by comparing the user's query vector with the list of vectors we have in the vector database, that will allow us to determine which vectors most closely match the user. So if you look at this picture here, this is more of a conceptual example. And here we can see the query vector. The original text for the query was kitten, right? And that represents this vector dot here in space. And all of the dots that are around the query vector are going to be words that are semantically similar to the query. So for example, here we can see the dot representing cat is very close to the dot representing kitten because those words mean pretty similar things. But words that are less similar, like banana, apple, chicken, whatever, those are going to be farther away because those vectors don't match as well, and the words are not as similar. So essentially, when the user passes in their query and we convert it to a vector, that's going to be compared to all of the different textual information that we have in our documents. And whichever vectors are the most similar to the user's query vector are likely going to be containing relevant information. So for example, if the user asks about, let's say, the capital stabilization fund, then the vectors that we pull from the documents using RAG are likely going to be the ones that contain words like capital stabilization fund, because the vectors that are most similar are going to be the ones that are semantically mean the same. And another one of the big benefits of using similarity search is that our chatbot actually features multilingual support. So obviously Lexington is a very demographically diverse town. And so we want to be able to answer users in whatever language they prefer. And let's say if the user enters their query in Spanish or French or Chinese or whatever, the way that the vector is embedded will mean that the vector is almost always very similar no matter what language you translate it into. So in this case, if you translate kitten into Spanish or French, it'll still roughly be the same vector as when you translate it in English. And so one of the big upsides of this is that our chatbot does feature multilingual support. To kind of summarize the process here of RAG, the first step is you take your PDF files and then you break them up into chunks of text, and then you convert that text into numerical vector embeddings using some sort of embedding model. And then you store all of the vectors inside of a vector database. Now, when the user enters a query, their query will be embedded into a vector as well. And then we'll perform a semantic similarity search that compares the user's query with all of the vectors in our database, and that will give out these ranked results, which essentially identify which vectors contain the text that is most relevant to the user. And so all of this relevant information will be passed into the large language model, which can then use that information for response generation. So essentially, instead of passing in entire files to the chatbot every time the user asks a query, we can just pick and choose which information we determine to be most relevant. So these are some more specific details about how we implement RAG into our chatbot. So one of the major upsides of using something like a chatbot is that you can interact with it conversationally. So you don't have to provide new context every time you want to ask a new query. So for example, if someone first asked, what was the school budget in the fiscal year of 2025? Well, that query makes sense. But then if they ask a follow-up, like, what about the 2 years before? Then we have to imply that what they're actually asking is what was the school budget in the fiscal years of 2023 and 2024, right? But just purely based off the question, what about the 2 years before? That doesn't mean anything by itself. And the way that RAG works is we're trying to embed the user queries into some sort of numerical representation. So what we really want is we want every query to have some sort of keyword that allows us to perform this similarity search and pull the relevant information. Because if we try to compare vectors with this, that's not going to give us anything useful. So what we did is every time the user enters a query, we actually prompt the LLM to rephrase it for us. So we pass in the context of the chat history, as well as the last query of the user, and we say, hey, based on what you know about the existing conversation, can you rewrite the user's query to include all the keywords, all the years, all the stuff that we need to perform RAG appropriately? So in our case, we would pass in this query, and the chatbot would come out and rewrite it as what was the school budget in the fiscal years of 2023 and 2024. And now this query has been enriched with all of the keywords we need to actually apply RAG appropriately. So we have school budget, we have the fiscal years, and that allows us to actually determine what information is relevant and what information is not. So this is something that's really, really useful for improving the search accuracy of the vectors we retrieve using RAG. But there are a couple of precautions with this. So the first thing is we're asking the LLM to kind of interpret what the user wants based on the context, but there's no guarantee that that's always correct. So sometimes the chatbot might interpret it wrong and hence might be answering the wrong question. We didn't find this to be a particularly prevalent issue in our testing, but it's definitely something to be aware of. And then another thing is, if the chat history is interpreted incorrectly, then all future queries will be rephrased under the wrong context. So these are definitely things you want to be wary of. In our case, we just didn't find that was a big issue because questions about municipal budget, for example, usually are pretty clear, and there isn't too much room for like variability or anything. But definitely something to be aware of. So this is something that we implemented into our chatbot, and this is very specific to the field of a municipal budget in particular. So if you've looked at, for example, Lexington's round of books before, then you know that they like to try to perform like historical comparisons where they say, okay, so here's our growth over time, or here's how this is, what's the trend over time. So in Lexington's round books, like let's say if you take the fiscal year of 2025, if you look at their 2025 round book, then they'll contain information from up to 4 years in the past. So they'll go from 2022 to 2025 in order to perform these sort of historical comparisons, see how, for example, like different appropriations are growing or shrinking and whatnot. And so our chatbot actually recognizes that if you're looking for information in 2022, that information might actually appear in the 2023 document, the 2025 document. So what we did is we performed this thing called metadata filtering, where anytime the user passes in a query, we can determine what years they're asking about and only fetch the documents that are relevant to those years. So for example, if the user asks a query about the fiscal year of 2022, then we know we only need to look at documents from 2022 to 2025. And anything before or after that, we don't need to look at because those documents aren't relevant anymore. So essentially all of our vectors are supplied with the metadata that tells us when that document was published. And so we can filter out all of the documents that are either too old or too recent using metadata filtering. And this is a significant improvement over general large language models. Like if you use ChatGPT, for example, they won't know this kind of information. And so the sources that they might be citing, they could be really old, they could be far too recent, they might not be even giving you answers from the correct years. So this is just to make sure that our answers to the user are from the right year. So this is kind of more on like the programmatic side of how we implemented RAG. So these are all kind of concepts that I've gone up over in the previous slides. So first, when we break up our PDF files into different chunks of text, we do that with a library called PyPDF Loader. And that enables us to break up the PDFs into individual pages, and then each page is going to be converted into a vector. And one of the really big benefits of doing things on a per page basis is that we can cite each vector directly back to a specific page of the documents. If you break it up by some sort of arbitrary metric, then it's hard to determine what page each vector is referring to. But because we did it on a per page basis, we know, okay, we pulled the information from this vector, which corresponds to this page of this document. And this helps us when we're giving citations back to the user. Which I'll talk about a little bit later. One of the kind of downsides of doing things on a per page basis is there might be sections that cover multiple pages, or start at the end of one page and then continue on to the start of the next page. So sometimes information can be broken up a little bit, but generally the chatbot is still able to pull the correct information. So this wasn't a huge deal. After we've broken up the PDFs into pages of text, we convert them into vectors. As I mentioned, we did this with one of OpenAI's embeddings models. I think it's called ADA 002. And then now we have a bunch of vectors that we can store in a vector database. We used ChromaDB in order to store our vectors, as well as not just the vectors, but also all of the metadata. So as I mentioned before, the publication date, the page numbers, these are all things that we want to store for later use. So after all of the vectors have been stored in the vector database, we can perform that similarity search with the user query. So first, when the user query comes in, we'll rephrase it to enrich it with all of the keywords we need. And then we'll convert the enriched user query into a vector. And then we'll perform metadata filtering. And at the final output of the similarity search is the set of documents that are both relevant and in the correct years. And so the retrieved pieces of text will be passed to the large language model to help it respond to the user. So this is the setup for how we hosted our chatbot. So a large portion of our chatbot is hosted on Amazon Web Services EC2. So first here, you can see that our vector database, which is stored using ChromaDB, is stored inside of an EC2 instance. And it's actually, furthermore, inside of this thing called a Docker container. So all of our vectors are stored inside of this Docker container that's inside of EC2. So this is where all of our documents are stored. And then the web server, so the actual application that you see when you go to the website, it is hosted on Streamlit, which is also under EC2. So I'll talk a little bit more about Streamlit in a second, but essentially it's one of the really common softwares that people use to develop applications with large language models. And then finally, the web server is where we host all of the documents that the people can actually access. So here in the Docker container, this is where we're storing all the vectors. But on the web server, we host the actual PDF files that people can access. And we host our own web server for the documents instead of referring back to, for example, like the Lexington town links, because when people click on citations on our website, we want them to be able to jump exactly to the page of where we pulled the information from. But if you look at the Lexington town documents, a lot of them are, for example, stored on Google Drive or whatnot, and it's not easy to go to an exact page from Google Drive. So we hosted all of the PDF files ourselves, and then we can direct people exactly where we want to go. These are big files, and we want to make sure people are directed to exactly where the information is. And then finally, on the side here, we also have a database under Amazon DynamoDB, and this is where we can log all of the users' questions as well as the the chatbot responses. So anytime a user asks something, we'll keep track of it in case we want to go back to it and review the responses later. Or if somebody has feedback for us, then we can look at what they asked and we can look at what the chatbot said. But of course, this is anonymous, so we don't store any like personal information. The only things we store are the query, the response, and then the user textual. They can provide feedback inside of our website. So if they provided any feedback, we also store that. But other than that, we don't store any sort of personal information. So one of the things that we did with our chatbot is we made it highly customizable. So if you want to develop another chatbot that uses the same framework but for a different purpose, like instead of municipal finance, maybe you wanted it for like medicine or something, then we made it really, really easy to switch around the kind of to the domain of our chatbot. So if you look here, these are all of our kind of configuration variables. So first, you have pretty simple things like the title, what town it's used for, the avatars, like the picture that the chatbot uses to respond to you. The sample questions, in our case, these are the sample questions for the new high school project, but you can change these for whatever purpose you want. There's also like some of the town-specific instructions. This information is used to supply the information of the ChromaDB database, the Chroma host and the Chroma port. So you can change that for whatever database you want to use if you have different sorts of databases. And then this part is really important here. This is the list of tools. So as I mentioned before, the agent is using tools to fetch different pieces of information and do different sorts of things. So for example, here, these are the two tools that we had for the LHS chatbot. We had one for all of the information contained within the FAQs, and then we had a different one for other information. This is because usually most questions could be answered with information in the FAQs, so we decided to separate that from all of the other information. So yeah, I mean, just by changing these variables, you can pretty much customize the chatbot to be for any purpose you want. Obviously, you'll need to set up another database for a different purpose. If you want to do that, you need to change all the tool information. But yeah. So in terms of the actual like the front end side, so what you actually see on the website, I mentioned this was built with Streamlit, and Streamlit is just one of the main softwares for building applications with large language models on the front end side. And one of the really cool features of Streamlit is that it has this thing called the session state. And using the session state, this is how we actually store things like the chat history. So all of the user's queries, all of the chatbot responses, this can be stored in Streamlit's session state variable. And that allows the chatbot to learn more about the context of the conversation every time it wants to respond to the user. It can go back and say, okay, here's what the user asked before. So based on that, here's how I want to respond to the latest question. And then for the backend, we used LangChain. So LangChain is also a really, really popular framework for building applications with large language models. So LangChain is the major library that we use to set up all of the backend side of things. So instantiating the large language model, setting that up, instantiating the tools that we use. This was all done with LangChain. So in terms of like the specific coding things we did with LangChain, LangChain is what helps us set up the different tool variables for our agent. And LangChain has this built-in superclass called base tool. That is essentially this kind of template for you to build your tool upon. And so we had this general budget tool and school tool, obviously. And I'll go more into depth on how we coded this a little bit later. LangChain also has this thing called an agent executor. This is the one that actually causes the agent to perform different tasks. So the agent executor will, for example, be the one calling the tools. It will be the one starting the agent. It'll be the one that's writing out the response. The agent executor is the one that actually does each task. And then the A-stream underscore events is essentially the list of different events that the executor will be performing. And I'll have like a code snippet with more about how this works later. And then, so what the agent is actually going to be doing is it's going to be deciding what tools it wants to use to complete the sub goals, and then also deciding whether it wants to collect more information and be repeating those thought action observation steps that I mentioned earlier. All right, so this is some code snippets about how we actually created our tools. So you can see here, we imported this base tool superclass that I mentioned here from LangChain. And the superclass has two main attributes. There's the name and the description. And it's really important that we write these properly because the name and the description are what tell the large language model when to use that tool. So for example, if we go back here to our configuration, we have this FAQ tool that says, and the description is, this is the FAQ tool, which will be used for high-level general queries. So this description is essentially telling the agent when should we use this tool and when do we want to use another tool. Because for every task, it has to decide what tool it wants to use, or if it wants to use multiple. So the description is what helps the LLM decide what tools to use. And then the base tool also has one built-in method, which is the arun method. So this is essentially the one that actually just that runs the tool and fetches the information for us. So that's what that method does. And in our case, we can also define some additional attributes, like, for example, a variable for where the vector database is in terms of the ChromaDB collection, as well as the web server location for the documents, because we want to be able to go back and cite those. So now here is an actual snippet from our code. So you can see here, first we're defining the list of tools, and then we're going to look over our configuration and look over all the tools in the configuration. So again, this is going back to here. So we're going to look over all of this information. And then we're going to instantiate a new tool with the information for each tool in the list that we defined. And then we're going to add that to the list of tools. And then when we instantiate the large language model, we can attach these tools onto the large language model. So this is kind of how we, this is essentially listing the entire RAG pipeline, but in code. So there's this big function here called get vector text. And you can see that the inputs here are the ChromaDB collection, the rephrased user query, and then the location of the documents on the web server, which is for citations. So the first thing we do is we embed the rephrased query, so we turn it into a vector. And then we perform similarity search. So we query the collection of documents with the new embedded query, the rephrased user query. And then we get the top 6 pieces of information that are the most similar to the user query. So this list of 6 vectors is essentially what's going to come out of the similarity search, and we expect this information to have enough to answer the user. And then now here, this is more on like the citation side. So for each of these vectors, what we're going to do is we're going to add the content of the information as well as produce a link for that vector. So you can see here in the link, we put in the doc location as well as the page number, so that way it directs the user directly to the page where this vector came from, right? And then finally, we'll be adding in the information, the similarity distance, which is essentially how close it is, the reference link, and then the text. So this is all the information that gets passed in to the large language model. And this is how we define our agent with LangChain. So again, the agent is the one that's deciding what tools to use, as well as like when to repeat those thought action observation steps. And so we define the agent with a couple of things. The first important one that you want to know is the chat history. So this is the list of all the things that the user in the chat will have already talked about. So that's going to be passed into the agent. And then there's also the agent scratch pad, which is kind of like a notebook. So the agent is going to take notes on, for example, like what tasks it's already taken, what information it already has. And so this scratch pad is essentially helping the agent formulate what it wants to do. And then attached to the agent, we put in the user prompts, the large language model with the tools, and then the agent output parser, which is essentially helping us put the output of the agent into the actual streaming server. And then the agent executor here is the one that's going to be running the agent. And you can see the agent is passed in as an argument here. So this is the run agent function. That essentially is the one performing the React side of things. And the main thing to note here is, I mentioned here, there's this AStream events function that contains all the different events that the agent will perform. And you can see there's many different kinds of events. So for example, there's on-chain start, which is the one that starts the agent, on-chain end, that ends the agent, on-chat model stream, which is the one that's typing out the response continuously. And there's on-tool start and on-tool end, which are the ones that are starting and ending the calling of the tools. So the system prompt is another really important part of the chatbot that helps us provide, basically, it allows us to provide instructions to the chatbot just in plain English. So for example, you can see this is our system prompts for the Lexington budget, or the Lexington High School chatbot. And you can see some of the information we gave here. So first, some sort of high-level stuff. You are an assistant that only answers queries related to the new Lexington High School project. For all other queries, politely refuse to respond. Yeah, so just making sure that it's staying on topic and it knows what its job is. Then we also say, your documents are up to date as of August 2025. You have access to official materials like reports from SBC, Thorne Whittier Architects, blah, blah, blah. So just telling them what sort of information they have access to, as well as how recent that is. And then this next one is really important. Do not take sides on debatable questions, provide only factual, neutral information, and do not endorse a position. So essentially, we want to make sure that we're committed to being non-political. We don't want to have a sway in influencing people's vote or whatever. So we're really just trying to inform and not persuade. And then we also say, generate your response by prioritizing the vectors with the lowest similarity distance. So lowest distance means they're the closest together, which means they're more similar. So essentially, just try to use whatever information is most relevant, and also adding reference links, so making sure that it cites things properly. So this is essentially just a place where you can give whatever instructions you want in plain English, which is very nice. So these are the instructions that we gave. All right, so now to go over how we did citations. So again, one of the really interesting things that we did with our citations is that they not only link you back to the document, but they actually go to the specific page where we pulled information from. And a lot of other general LLMs like ChatGPT, for example, didn't do that, at least back when we were first developing this. I'm not sure if they do it now. But the way we did that, again, is because we chunk our PDFs on a per page basis. We know which page every vector is referring to. And so we can construct a citation URL by giving them the link to that source in our web server, and then adding in this pound page is equal to whatever page number that vector is associated with. And that allows us to essentially generate the citation that puts the user directly on the page that we want them to be at. And obviously citations are really important for us, especially since this is something civic, because we want users to be able to trust what we're saying, and we also want them to be able to verify responses themselves, so that way they don't have to just blindly trust what we're saying. And if you've used our chatbot, another thing you might have noticed that we do differently than other chatbots is we actually provide the users with suggested follow-up questions. So every time the user asks a question, we'll prompt the large language model to come up with some good follow-ups for them if they want to continue that line of inquiry. So you can see here, we asked the LLM, given this chat history, suggest 2 follow-up questions the user might ask next that are related to the new high school project. And then we display those down here. So essentially, if the user wants to continue asking questions about related topics, we allow them to do that as well, and we give them some suggestions. And so this is more for us than it is for the user. But I mentioned before that every time the user asks a query, and every time the user comes back, or the chatbot comes back with a response, we want to be able to store that in case somebody has feedback for us and we want to review what they asked, as well as what the chatbot said. So this is how we logged all the information. So you can see there's a couple of information that we have here. First, we have the ID, and this is really just like a unique string that tells us what query it is. And then we also include timestamp, the question, and then the chatbot response. And then we also put some stuff like metadata and feedback. And then we put that into the chat table, which is linking back to the Amazon DynamoDB database. That's kind of like a high-level summary of the flow of the chatbot every time the user enters a query. So first, the user will enter the query into the Streamlit web server. Then the chatbot will rephrase that query. And then the React agent will sort of decompose the sub-goals and select tools and then perform RAG as necessary. And then once RAG is performed, we'll get back the relevant information from the PDFs that will be passed into the LLM. And so the React process might be repeated several times. It might only pass one time, but the end result is that the chatbot will have access to a wide variety of information that it can then use to answer the user, as well as provide citations and follow-up questions. So now to go over how we did our testing. So obviously we had to do testing because when you're dealing with things like AI, there are concerns over hallucinations, accuracy, bias, all these sorts of things. So we actually had many different groups, or we requested many different groups to test our chatbot. Of course, we personally did a lot of testing. One of our team members, Justin, did a lot of testing for us. We also asked the town meeting members back in 2024 before the annual town meeting. The Appropriations Committee, the chair, met with us once or twice to kind of go over some of the questions that he felt could be improved, as well as tell us a little bit more about how the municipal budgeting system works, so he could help to make this chatbot as accurate as possible. Yes for Lex, which is the supporting group for the new high school project, also helped us do a little bit of testing. And we contacted some members of the opposition movement, but we didn't hear back from them. So Yes for Lex were the ones who decided to help us test. And then there were also many different residents who emailed us with their own feedback and their support. So we had lots of different people who helped us get the chatbot in the shape that it is today. And a lot of the feedback that they mentioned actually ended up going back into the system prompts. So all sorts of different things that they thought would be useful. Sometimes we literally just instructed the chatbot to kind of incorporate that feedback. And then some other things that we did to try and minimize the concerns over AI. So the first thing is we had a lot of humans that were reviewing the actual response that the chatbot gave. Some of them, for example, were us students. Some of them were actually people who are, to some degree, involved in municipal budget, or at least are knowledgeable in that field. Another thing is, again, storing the logs with all of the queries and the responses that came back in case we want to go back to them. And then two things that we actually did on our website. The first is that we published our data set on our website. So anybody who wants to look at that data set can go look at it for themselves. And if they feel like it's not comprehensive enough, or if they feel like there's too much on one side, not enough on the other side, they can always contact us about that. And then finally, we added a disclaimer just to say, this is an AI project. You can't guarantee that the responses are going to be 100% accurate 100% of the time. So we encourage you to verify things yourselves and take everything with a grain of salt and use your own knowledge to supplement what we're doing. And this is something that we're thinking about for the future, where we want to automate our testing framework. And the way that we could do this is that we can have an external LLM evaluate how our chatbot is doing. And obviously, this needs to be a blind evaluation. So this external LLM that we're using, we can't tell it that this response was generated by a chatbot or something. All it'll know is, here was the user's question, here is some expert verified answer, and here is what the chatbot came up with. But it won't know that it was a chatbot, it'll just know this is some response. And we wanted to evaluate the chatbot's response based on some sort of standardized framework. And so here you can see it can categorize the chatbot response in different categories based on how good it is. And essentially, we're hoping that by designing this framework, we can sort of mitigate some of the biases that human reviewers might have, and we can standardize the whole framework by using an LLM and try to make it as objective as possible. And one of the really nice use cases for this is if we ever want to update our chatbot. So, for example, if we want to use a new large language model for our base model, then we can try a whole bunch of different options, pass them through this testing framework, and see which one performed the best. Because everything is standardized, it's all benchmarked. So it'll be much easier for us to evaluate which models are better, which models are worse. And just to go over some explicit comparison between what our framework has done versus general LLMs like ChatGPT. So the first thing is that because we're implementing RAG, we're supplying the chatbot with documents that we know are going to be up to date and are going to be authoritative. Meanwhile, ChatGPT might refer to outdated or unofficial sources that they found on the web. So we're confident that our documents are going to be trustworthy. Another thing is we have all these sort of domain-specific things. So for example, I talked about metadata filtering. So we're only supplying the chatbot with documents that are in the relevant years, while ChatGPT has access to everything that's on the internet, whether it's accurate or not. So we're really controlling the flow of information, so that way we're as confident in it as possible. And another thing is our chatbot is focused on trying to be neutral and trying to be non-political, while ChatGPT wasn't explicitly trained to handle topics like municipal budget. So it may have some sort of biases. It may try to persuade you. It may give you some sort of decision if you ask hard enough. But we're really, really focused on neutrality, so you really don't want to make any decisions for the user. And now, for some future directions for this project, the first thing is we're hoping to improve our UI. As I mentioned, we're currently using Streamlit. And Streamlit, everything is very templated. There's not too much customizability, so it looks very similar to many other Streamlit applications. So hopefully we want to switch to another UI framework and perhaps be a little more customized with it. Another thing is we want to support other media formats for our documents. So I've been talking about PDFs this whole presentation, but there are many other sources that the town has access to. So for example, many documents have figures and images and diagrams and stuff, but we can't support that right now just because the embedding model converts text into vectors. It can't convert images into vectors. And obviously that's a much more complicated process, as you can imagine. So currently we don't support that, but we're trying to figure out if that's something that we can incorporate support for. And then there's also things like meeting transcripts, which we currently haven't included. We've only included official just documents. And there are some concerns over meeting transcripts because people can say things and realize they're wrong and then take it back later, but that text will still appear in the transcript. So it's a lot more complicated because they aren't vetted as rigorously as the official documents that town publishes. But one of our teammates, Jasmine, is looking into whether we can make that possible or not. And then another thing that I think a lot of residents are curious about is the comparison between Lexington and other towns. So a lot of times people want to know, especially for the new high school project, is how does this cost compare to other towns? How does the student body compare? What is the per student cost? What is the per square foot cost comparison? And all these sorts of things. So we want to try and enable these sort of inter-town comparisons. The Lexington documents already has some degree of comparison between Lexington and the other towns, but obviously it won't be as rigorous as incorporating other towns' documents directly as well. So these are directions that we're investigating for the future. And so I would like to acknowledge all of the people who helped support this project. So first, for our mentors, we have Professor Wei Ding, who's here with us today. Was one of the main mentors from the Use Team Initiative side, as well as Jenny, who was another mentor on our side. And then we had several people from the Lexington Observer side who helped us throughout this process. So you have Andre, Nagarjuna, Chester, and Nico, who all helped us greatly in the development of this chatbot. And then this is the list of all 9 teammates who had some part in the project. So Justin, Jasmine, Jolie, Kevin, Cassidy, Emma, William, and Andrew, they all helped in this project. And specifically, Justin, Jasmine, and Jolie were also involved in developing the LHS chatbot, while the rest of them worked on the original Lexington. So that's the end of my presentation, and now I'll open it up to you guys for questions.
All right, very good. Thank you very much. Why don't you take down your share so we can see people on the screen, and then we can go from there. John, yeah, and well, I think Steve is doing this. There we go.
Since I'm really impressed with how much you and presumably the others know about all this, it's astounding. How did you learn all this?
Well, there's a lot of resources online. So particularly on the coding side of things, a lot of these, so for example, like Streamlit and LangChain, they have like sample code snippets that you can use that can help you design your own application. So a lot of the code is actually, I took an online template, I modified it, I put in all of my custom stuff, and then it was much easier to work with because I'm not exactly writing everything from scratch. A significant portion of the project was done just by reading online documentation, looking at examples, and then taking their code and modifying it for our purposes. And yeah, there's also like a lot of videos online. So everything is well documented nowadays in terms of all these different coding libraries and everything. So I would say that I think, especially in the past few years, it's gotten much, much easier to work on coding projects. And of course, if you need help, you can always ask like ChatGPT for something, for help or something.
That's right.
Yeah.
ChatGPT writes a Python code that does X, Y, Z.
Yeah, yeah.
And it comes out pretty good.
If you need help, ChatGPT is probably save you a couple hours of time that you would spend, debugging an issue, and instead ChatGPT can tell you in 10 seconds. So I think you have a lot more resources nowadays than you did even like 5 years ago.
We used to have to go to the playground.
Yeah. So I think for sure, it's a lot easier to find resources online that can help you. And of course, we had our mentors. So several of our mentors, both from the Youth Team Initiative side and from the Lexington Observer side, have been working in the CS industry for quite a while. They're quite knowledgeable, and so they definitely could provide advice if you need it.
CS industry, just help me with what CS is. Computer science.
Yeah.
Oh, thank you. Thank
You
you.
remember the one you were used to be involved in?
Yeah, I did something on that a while ago. I forget what it was. All right, great. No, hang on a second. I'm going to drive.
Oh, okay, I see.
Olga, please. You're muted, Olga, please.
Can you hear me?
Yes.
I must admit, I'm truly impressed by what you guys have achieved, and thank you for doing that. I became a computer scientist. I decided to become a computer scientist back in the 70s. And so I'm a dinosaur in technology. But one of the things that seems to me that has not changed is we techies sort of always strive to do better using the newest tools, looking at different ideas and trying to implement them. And we don't get enough chance to think about the impact and the implications of the work we are doing. So one of the things that you have done a lot better than was done in your user excellent and very friendly. The concern I have about the chat box, and in particular the way it was used for the high school project, was using limited number of resources. And the problem with the chat box that I found was that the project was far more complicated than the resources that you had access to. And therefore, it didn't present opposing point of view. And the question I have is, how do you decide when the chat box is a good thing to use and when the chat box doesn't have enough information so that the answers is going to be presenting are going to be biased.
Yeah, so I'm not really an expert on the Lexington High School project. I mean, I know enough to figure out how to get this project set up. But really, it's definitely difficult to get access to a perfectly comprehensive set of documents, and it's also very difficult to make sure that all of our documents are accurate. So I think I really wanted to address the latter issue first, where I tried to ensure that at least the information is correct. And the easiest way to do that was just to take the documents that were released by, the school building committee, Dorn Whittier Architects, all of those sort of like official sources. We want to make sure we talk about those. But other sources that are harder to verify, we try to stay away from, especially since we as students couldn't verify those as easily as someone who's an expert on either the project or municipal budget or whatever. And in terms of like the opposing viewpoint, I'm not really sure what sort of documents that they had access to because based on what I saw, a lot of the official documents were more like, okay, if we were to do this, here's the list of proposals here's the list of things that would change. Here's the pricing. Here is the pricing compared to other schools. And there are also some reports that say like, okay, here is what is currently failing within the current school. And so it's definitely true that some of it might be interpreted as if this is to happen, then here are the consequences. And not if this is not going to happen, then what will stay the same, what will not change or whatever. But I do feel like that the way that the chatbot responds tends to state more of the actual statistics and less about like or more like either statistics or official statements and not necessarily trying to say this is a good idea or this is a bad idea. And how you interpret those statistics is obviously going to be up to the user.
I'd like to, I think you're saying you were focused on the school building committee's provided data, which is fine, because that's what they're willing to stand behind. If the other points of view were to be included in this, those people would have to do a lot of work to get their data in the same form.
Yeah, for sure.
That you could take.
And verify.
Yeah,
and verified is always a very difficult word because especially when there's a lot of hypotheticals going on.
Right.
Yeah. I think the school building committee definitely has put a lot of work into making sure that their information is as good as they can get it. And there actually were a couple people from the opposition side who contacted us about, saying, oh, maybe this information is wrong, and here you can look at my information. But
how could their information be wrong? It was about the school committee's project. That's what they were answering questions about.
Yeah, it's definitely up to interpretation. And it's unclear.
Your bot wasn't an attempt to settle which one was right.
Yeah. And I've definitely received requests from the opposition side to add in different sources. Like, for example, one man came to us and had his own spreadsheet of information. He said, look, here are the statistics that I have, and they disagree with whatever statistics are in the set of documents that you have. But it wasn't at my in my power to say for certain whether that was right or wrong. So I just stuck with whatever the school building committee had because I figured that their documents, it's their proposal, their documents. They seem to put a lot of effort to verify the sources. So I wasn't completely sure if I could trust, a different sort of personal statistics.
But that provides a bias.
Yeah, for sure. Because if the resources on both sides were equal and the information on both sides was vetted appropriately or peer reviewed, if I can use that phrase, right? So that we had a level playing field. I think the criticism that Olga is making is 150% valid. However, when we have validated information on one side and information that is basically, I'm going to use the phrase people's opinion, just for lack of clarity, just as opposed to being independently verified and saying, yeah, this is a better number than what the school committee used. It's hard to compare the apples and oranges that are going on there in a reasonable way,
Yeah, for sure.
without biasing the whole process.
I have a
This is what
question.
John Day is saying.
I understand.
Yeah,
I understand. Thanks. Go ahead.
I have a question about one of your slides. Just, I didn't understand it quite. And it must have been in the beginning. But it was where you were talking about a database that looked like you were assuming it was three-dimensional. There you go. Go
Oh,
back.
this one. Yeah.
This one. This one has 3 dimensions.
Yeah.
How
I
many
mean,
dimensions does it actually have?
many more than 3 for sure.
Okay.
47,000.
No, I just want to make sure we
Yeah.
all understand that this is
minus
much
3,
more
more or less.
complex than this.
Yeah, yeah. I think
to
this
get
is
it right.
more of like for a conceptual understanding. You can see
Yeah.
how like
Look at
points
the
in
upper
space.
right.
Right? Yeah. We're about
This is
How many
300.
dimensions?
This is just an example.
Oh,
picture.
300 dimensions. Okay.
But this
Yeah,
isn't. Yeah,
that's
this
an
isn't.
example.
This isn't a picture.
But I think this is an essential thing for us to understand the fundamentals of LLMs.
Yeah.
They are so huge that it's very hard to. It's like the astronomy. You have to think about how many stars there are in the universe.
Yeah.
That's what this stuff is getting to. And I was thinking, well, okay, so is a cat in French land in the same area as a cat in English?
Yeah. Because
It
the way
does,
that the way that the vector works is that it's embedding things semantically, so it's based on meaning,
Right.
and obviously in different languages there might
Well,
be
it's
some
not
slight
so
difference.
much. I mean, it is. It's not like the old semantic AI, which is the way they used to do it when I was at MIT and Marvin Minsky ruled the world. This is completely different, but it's arriving at the same thing, which is that little glow of yellow.
Semantics are emergent in this model, right? There's no semantics brought into this.
Yeah,
Yeah, it just happened. Well, if it's for it to work correctly, it has to show it semantically the same, but it's not arriving at it by saying
It's similarity.
Gateau in French and the cat in English.
It's like a neutral interpretation.
I'm
Yeah,
sure
yeah.
that's right.
Right.
So what's the rough cardinality of the matrix, in terms of vectors and how many words are in it,
Dimensionality?
how wide?
Yeah, dimensionality. It's not going to be a matrix. It's a vector. It's not going to be like a higher dimensional tensor or anything. I'm not actually sure what the dimensionality is, since I didn't actually code up the similarity search itself. I can just call a function, right?
Yeah.
Right.
So I'm not actually sure what it would be, but I would assume it would be quite large.
Along the same line as this,
Infinity,
you have to make,
One at a time, please.
you have to make certain assumptions about how you're correlating the information that's coming in there. The thing that I'm hung up now and trying to understand large language models and how they're working is how you program or how you come across the way that you make the statistical analysis. In other words, how do you decide that this term is close to that term, or how do you have the machine do it? How do you program it so that you make it coalesce into some sort of an answer that makes meaning? Because you're doing statistical analysis, right? In terms of your program.
analysis
Right.
anymore.
Do you mean like in terms of like a similarity search, or in terms of like writing the response?
And in terms of the actual programming that you're going through. In other words,
Deep learning model.
it seems to me that you've got vectors but you have to make some sort of statistical
Oh, like how close
analysis.
the vectors are.
Yeah,
Yeah. So this is actually the function that I used for similarity search is more heuristic. So it's not exactly calculating all these distances, but on like a theoretical level, the way that you would compute how similar two vectors are is you can compute something called the Euclidean norm. And this generalizes the higher dimensions very well. But essentially, the Euclidean norm is sort of an n-dimensional generalization of distance. So if you look at like the Cartesian plane, for example, you can calculate the distance between 2 points using Pythagorean theorem, right? So you just apply the same thing, which is now called Euclidean norm, but in n dimensions. And preferably, things that are closer should be things that are more similar. And so because everything is working with vectors, it's much easier to have rigorous numerical comparisons. In our case, we don't actually compute the distance between every pair of points, just because that would be really, really slow. Instead, we use heuristic algorithms. So it's like, okay, these points are generally closer than these points, and that makes things much, much faster. But that's kind of the concept behind it. Yeah.
So the new approach using deep learning model.
Yeah.
So the old way, you actually calculate the distance. You really
Right.
calculate distance.
right.
Now the what makes the new revolution in the AI technologies is they're using deep learning model. Okay, they're using large language models. So basically, we make a call to the ChatGPT. Okay, so the ChatGPT actually build a whole world model for all the knowledge that can be accessed through the internet. So this is the thing make AI become so powerful, because the thing is, it actually has the power to reach out to the entire human knowledge. And then it's open the API to regular people like us. Remember last time I talked about the intelligence become cheap, because it used to be quite expensive. You want to access the knowledge for the whole human history, you have to be either rich, you have either be powerful. But now with hardworking, talented high school student, Jerry. Jerry is one of the best students in my team, okay? So he's leaving, we're going to miss him. So, but then the thing is, Jerry will be able to use those AI tools to serve Lexington. Okay, and I agree with Olga, and also what Peter mentioned about the resources kind of like it's not 100% fair, right? Because we have one side, we have school committee organized at first, then on the other side, we have Olga, and Peter, the other people who kind of like, individual person.
Right.
But though I feel it's outside scope for the chatbot.
And to your point, if I understand your point correctly, what you've done is you've leveraged all the work that ChatGPT is doing under the covers.
Yes.
You call ChatGPT and say, give me, the answer to this.
Yes.
And it goes out, it figures out, on a probability basis, what the right answer is, and it gives you the right answer based on the heuristics based of ChatGPT.
Yes.
And then you move from there.
Yes.
Because
and Jerry spent lots of time to figure out how we can leverage what has been done by ChatGPT.
Exactly.
To provide better answers, because his chatbot actually can provide much better, much more accurate answers for the regular ChatGPT.
Right, because he's more focused and narrowed the search.
Yes.
Absolutely.
Yes. He spent lots of time.
No, and that's the beauty of it.
Yes, and what's really amazing is he got this done when he became a senior student. So I really admire how he can, contribute his free time to do the things to the entire community. So
he doesn't sleep. It's okay. He's young.
You can tell that.
He has a whole lifetime to sleep later.
When it gets to our age.
John Day.
Sure. First of all, Jerry, thank you very much for a comprehensive and interesting presentation. Relative to development, both ChatGPT and Claude have significant capability.
John?
Excuse me?
Can you talk a little bit louder?
Sure. Is that better?
Yes,
That's
yes.
better.
Okay, sorry. What I was saying is both ChatGPT and Claude have significant capability in handling projects. They both have a mode called project mode, where you can load up significant amount of data into the project files, and then it pre-processes that in ways that you were referring to as, RAG technology, turning things into vectors, embeddings. And this might be an interesting way to do some prototyping. In other words, be free from having to write all that code and get a good idea. And I would be quite surprised if you, after you've gone through this prototyping effort, particularly with Claude, that you couldn't just prompt Claude, give it an existing code base and say, augment my code base to implement what we've learned in this prototyping cycle.
Okay, we have two questions back here.
I'm just going to comment on this first.
Yeah, please do.
I actually didn't know about this cproject mode thing. It sounds pretty similar to something that we worked with near the start of this project, called OpenAI's Assistants API, where they let you create an assistant where you can add your own documents. I think the reason why we decided to create our own custom framework is because, first of all, we wanted both RAG and React as a part of this framework. And Assistants API only gave you one, which is RAG. And the second thing is we had a vast amount of documents that we wanted to upload, and uploading them manually and then having to do that every time we wanted to ask a new question was not particularly efficient. I'm not sure if there's a way you can like save, like for example, with this new project mode, you can like save a specific like chatbot with a document base. But I think with our current chatbot, everything is already set up for you as soon as you enter the website. So I think that was nice, but I'll probably look into it. Yeah.
Well,
Yeah, one of the problems you run into with the quality of the data or disagreements over whether the documents are reliable has to do with the fact that a lot of the decision-making for the new high school was based on projections of need, of future need. And that's never certain. So you can have divergent conclusions based on the same data, the same original data. It depends on being able to analyze trends. So were there ways of taking in outside sources that had made different projections and taking that into account?
Well, it really depends on like, even if you make different projections, some people can utilize more data, some people can be peer reviewed. And I'm not in a position to say this person's projection is right or wrong, and this trajectory is right or wrong. Really, the only data that's for certain is, for example, in the LPS educational plan where Julie Hackett said, here is the list of things I see in the current school that need to be fixed or need to be improved. And that's the stuff that is actually for certain. In terms of the stuff saying that says the new school will fix this or the new school will support this, I can't speak to that. But preferably, I would rather use sources that have more thought, more review going into it.
you're right. Projecting the future is an art form.
Yeah, and this is why I'm saying the opposition had some projections and certain assumptions.
It goes back to what we talked about before, is that if there was some way to create a level playing field where everything was evaluated, peer reviewed or something in some way, so that the A team and the B team, if you will, to use those terms, had equal leverage or equal ammunition or whatever you want to call it. That, it's a wonderful thing to do. But
I agree with these comments completely because I feel the school committee actually should create such data pool to allow people like Olga, Peter, to upload their data there, and then we can have a certain kind of peer evaluation system. And then,
right.
I feel this is really the responsibility.
And that's one tool. It's after the fact that the town has spoken, but it's a lesson learned for going forward. It's one tool. What does peer review mean? Certainly, peer review of the school, the government's position.
Yes.
Would be important. They can be just as biased as somebody doing their independent research, and that there's nothing you can do about that. But the government stuff is what's publicly available versus what other people have done.
Are not publicly available. They're embedded inside the Facebook
the logic behind
channels.
it is not publicly available, and that's a very political question that I really don't want to go into it in this.
Maybe they should be aware of these type of things because even they have conducted more than 200 meetings with the residents, right? Yeah. However, the inputs from people like Olga, Peter, their input are embedded inside the meeting minutes, inside the Facebook channels. The government actually does not provide an equal, transparent way for the people to upload their opinions on a shared, interface, and then give the other people fair chance to vote for their opinion.
Yeah.
So, but I feel this is not the responsibility, obligation for our own volunteer team. Okay, our team focus on, technologies. We focus on to use, advanced AI tool to help the community. But then what has not been done by the government?
It's true. There were opportunities, I'm just speaking for myself as a citizen.
Yes.
There were opportunities to give equal balance during the town meeting.
You're right.
For both sides, in a formal presentation to explain, your data says this, my data says this, and here's the assumptions I made with my data to get me to this point.
Sure.
So that there's, full disclosure. And that's a way of validating. At least it creates a level playing field. And I have to honestly say, I don't know if that occurred during the town meeting process.
I don't think so.
I can't answer that question, and I don't want to. But I'm saying it's something we can use as a lesson learned going forward in terms of these kinds of things to try to understand how we can level the playing field. Because important decisions like this require opposing points of view. Be able to do things. You know, you need somebody to say this. I don't think this is right. You know, and why. And so we're intelligent. We know what to do, especially in this town. You know, it's like Lee Wobegon. Everybody's above average.
Yes, you're right.
You know, we can make intelligent decisions, and we should, and we try to. But, you know, we're human.
Yeah,
Jerry.
To get off the politics, I mean, trying to go from facts to wisdom isn't that easy with an LLM. But I'm a physician. I did it was a wonderful presentation. I did a one-man band project, which is a tiny as compared to what you did. I did a medical meta-analysis as an experiment with 5 data chunks, basically 5 medical articles that I had to find and put in and to answer a question. And so I did the RAG so manually, and I did the REACT over and over. And I still found that the output still needed massage for concept. The medical concepts are more complicated than they cost $600,000, but they needed some massage for concept clarity and precision. What is your own personal perception as to when you ask a question into this LLM, into this chatbot? What is your impression as to the clarity and precision of the answer as compared to the question? What's your personal impression?
So I think the words we actually had like a similar kind of idea when we did our testing, but we didn't use the words clarity and precision. I think comprehensiveness is one of the big words that we used, and accuracy was probably the other one. So in terms of comprehensiveness, one of the big concerns was we wanted our queries to make sure that it provided as much like relevant information as possible, you know, without diverging off topic. So there were definitely scenarios where we would ask, you know, let's say we asked ChatGPT something, it would come back with like one statistic or like one line, and like that suffices to answer the user query. But there are also additional details that you could provide. So we really wanted our chatbot to provide those additional details if it had it. So in our testing, we definitely tried to make sure that like the breadth of data coverage was good. And then obviously accuracy, not quite the same as precision. In terms of precision, like in terms of consistency, the chatbot's very consistent. And that's just kind of the way that a lot of these LLMs work. So our base LLM is from OpenAI. And if you there's like this parameter called temperature, which essentially tells the chatbot like how loud it can go. And ours was much more on the conservative side. And essentially what that means is if you ask the same query, you know, 10 times, the response is going to be very, very similar, you know, like 9 times out of 10.
And your impression of the quality of that response?
I feel like the quality is generally pretty good, but also, as you mentioned, like medical data is, especially if it's like a paper or something, it's much more likely to be more complex. There's like more analysis involved. And for our chatbot, I think maybe like 70% of the queries that we get are literally just going to be pulling some sort of data from the document, and we just, you know, spit it out to them. And normally we don't have to do too much analysis. Our chatbot can do things like compare statistics or like look at growth rates, and it can like pull all of the relevant information and merge that into some sort of analysis. But I didn't feel like there was any major issues. At least like the latest version of our chatbot didn't have any issues with quality.
To be clear about accuracy and precision for the group is that if you're have a scale and you, in God's truth, weigh 150 pounds, if you step on the scale and it's 149, it's 151, it's 150, it's pretty accurate, but it's up and down. Precision, you step on that scale and it says you weigh 22.8 pounds every single time. It's very precise, but it's not accurate. And so I'm wondering what the quality, because I had trouble with this with the meta-analysis, getting good precision and good clarity, which is sort of like accuracy. I just found it wasn't that I needed to work with it beyond that.
Yeah. So I was, you know, when I talked about precision, I was saying that because our temperature was a little bit lower, that made it consistent. So, you know, as you mentioned, it's mostly giving the same response every time you ask the same query. In terms of accuracy, yeah, accuracy was definitely probably I would say it's the single biggest focus of our testing, where like essentially we were trying to make sure that none of the statistics were wrong, none of the information was wrong, right? So that's why we had a lot of different groups test our thing, and a lot of people did come up to us and say, "Hey, this is wrong," or you should fix this, or the statistic was given incorrectly. And sometimes we found that to be true, and we tried to make modifications or massage our framework so that way it would accommodate those changes. And then sometimes we reviewed it and we found that the documents were cited correctly and the information was cited correctly. So we didn't find any accuracy issues. But there were definitely times, especially earlier in development, where we had accuracy issues and we tried to fix them. And I think in the latest version of our chatbot, the data tends to be accurate. I think it gets a little bit iffy when you have to consider that some of these documents are being updated like once every couple, like every 2 months, 3 months, whatever. Especially with the high school project, the timeline on the planning for this was very fast relative to the timeline of our development. So, like making sure that the documents were up to date was definitely something that we have to think about more with regards to the LHS chatbot than we did for the Lex budget chatbot, where once those round books are published, they're probably not going to get changed that much. Or if they are going to get changed, it's going to be a very small change. Like the statistic might change by 1%, 2%, right? So with the LHS chatbot, we really have to think more carefully about that. But one of the really interesting features that we did with our vector database is that we have a set of scripts that allow us to modify the database very, very easily. So we can add new files, we can delete files, we can update files. These are all things we can do pretty much like very, very easily by just running these scripts and then putting in the right parameters. So making sure that things are accurate is it's definitely the hardest part, I'd say, of this whole process, especially when things are changing. But we've tried to do things to accommodate that.
Olga has a question.
He has questions.
Hi, am I on?
Yes, you are.
Hi. I guess I'd like to get back to the actual impact of chatbots, use of chat boxes. And that's not just you, it's all the current use of AI. And clearly, your advisors were aware of the deficiency of access to different viewpoint. And also, you didn't to many of the state documents, and in particular, the environmental agency that was trying to decide about the impact on wetlands. And in my opinion, box was not ready for the use to which it was put, because it clearly had so many deficits that it was biased. And this is not a criticism of the technology, it's a criticism of where do you apply the technology. And as somebody pointed out, it is extremely difficult to deal with projections and getting projections validated and implementing or comparing person A to person B projection. And the question I have is, have you thought about when to bring the chatbot to public use and when not to? Because I can see, I think your chat box is absolutely great. And I can probably give you about 10 different applications where the data that you can have access to is there, and it would be very useful. I don't think that using it for the LHS project was either a good or a fair box. And the question I have is, who in your group makes these decisions, and do you have discussions about, it would be cool to affect how the high school project goes on, but is this an appropriate use of the chat box? And and perhaps to
Let's take
the
care of
entire group.
political issues.
I agree with you, Joe. Olga, I think we should ask some technical questions as opposed to just political questions. That's what we're getting into.
Yeah, I mean, just to clarify, based on what you've already mentioned, I'm not the one who actually, like, I obviously am the one who will eventually deploy the chatbot, but we have a lot of discussion with mentors, with different local community stakeholders before we decide to go through with it. So all of those groups that I mentioned who we passed through with testing, that was all prior to release, both for the LHS chatbot and for the original X budget chatbot. So, we passed through town meeting members, we passed through residents, we passed through the Lexington Appropriations Committee. Yes for Lex also gave us their insight, and they actually told us, hey, maybe you should add these official town documents, or you should take this from like Dorian from Dorian Whittier, from SBC or whatever, because they thought that included additional statistics that could be useful for all residents, regardless of their position on this debate. So we went through many stages of refinement, and many people reviewed the chatbot before it went live, and we figured that in October that was the perfect time to publish, because we were at a stable point in the chatbot where we felt like it was performing well, and it was also giving residents enough time to play around with it before the town vote, because if we published it too late, then it wouldn't really have that much effect. So we really wanted to. I think October ended up being the best choice of time for us to deploy the chatbot. And I feel like you can always find someone who believes there could be more prep done, or that things could change a little bit. But based on the opinions that we collated from all of the adults and professionals we talked to, we figured that October was a good time where it was ready to publish.
Let me ask you a question about the future. You have a team of, I don't know, 15 people more or less that are involved in this. I'm guessing that a lot of them are seniors. Where is this whole, I'll call it project, where is this project going over time? What do you expect to do?
Yeah, so I mean, in particular for the idea of the LHS chatbot, and that vote's already passed.
Yeah, no, that's why I asked the question.
Yeah. But our framework has, as I mentioned, is something that's very customizable. So if you want to adapt it for a different purpose, that's something that's definitely doable, and much easier than writing something from scratch. And there are some younger students on the team who I'll pass this project off to. And I think they could definitely take it in interesting directions. I'm not sure if they want to stay local to Lexington, if they want to move, either a different town, a wider area, like maybe all of Greater Boston, maybe even something national. I'm not really sure what direction they want to take it. But any time you want to do something that's like domain specific, I think our framework is something that's applicable. And actually, we've also been reached out to by a couple of different people before, because we had our research paper on this and that was published. And so we got a little bit of publicity out of that. And so there are different people who have reached out to us and said, hey, either I'm doing something similar, do you want to talk this through? Or, hey, I really like this idea. Do you think you could perhaps apply this into something that I'm doing? And so a lot of these collaborations are still in the very, very early stages, where we haven't made anything official. We're still meeting, we're still planning. But there are definitely options for how we can take this.
To what extent is going to be used in Lexington, like for the next town meeting or for another override kind of situation? I mean, is there a provision? Is it parameterized enough so that someone else could fairly easily take it and apply it to something else? Or having been a software developer, I know your answer is going to be no, because you did it the first time, and it takes something to make it really truly bulletproof.
You have to make it ubiquitous. It's hard.
Yeah. I think you need a pretty solid understanding of the code base if you want to adapt it. It's not, even the setup itself is not something that's completely trivial. So I would say some of the younger students on the team who have worked on this and have done some coding themselves, they'll have a pretty good understanding of the code base, and I have my confidence that they'll be able to take it from there. But I don't think it's something where anybody in Lexington can just take my code, be like, oh, I'll just change a couple things here.
How much of the team are seniors?
There's
many.
Some of the students have actually already graduated, but there's currently 3 of us who are seniors.
Yeah.
Where are you going to school next year?
I'll see you in March.
Oh, okay, all right. We're hoping, there's a number of us here who are hoping that you're going to a school with 3 letters in
Yeah,
the
well,
bottom.
I think that was prior, but that's a different discussion. He's actually hoping to get help from Google.
I
That's what
see.
he's hoping for.
We'll see. We'll
The
see.
hell with Colin.
Maybe
What do you think of Claude?
Oh, I'm Dave Dunn.
Claude?
I'm John
Well,
Ruby. Nice to meet you.
so my
I'm
experience with
Dave
AI is
Dunn,
actually
86.
fairly interesting. So I think
67.
I use AI for a couple of different things. But one of the biggest things I use it for, or at least one of the biggest things that I'm interested in, is its mathematical development. So I do a lot with math. I'm a math team captain at LHS. So I've always been interested in how that's developing, especially in the past few years, as news of OpenAI gets their hidden model gets rolled at IMO, and then Gemini 2.5 Pro, or not 2.5 Pro, but one of Gemini's hidden models gets rolled at IMO as well. And so I've always been interested in how that's developing.
IMO's
In terms
International
of
Math
that-
Olympiad.
Yes. And in terms of that, Claude has always been a little bit lower in the rankings, but yeah. So in terms of like math
But I
and
mean, from
coding,
the standpoint of programming.
yeah, I think people have always been of the opinion that, especially now that there's like O3 and like Gemini, like what is it, Nano Banana or something Pro, something like that, and then also Grok is allegedly pretty good, but I'm not sure how much I believe that.
I guess the point I'm trying to make is
If you want pornographic pictures along with your code, Grok is perfect.
I'm trying to make the point that you can leave a body of code if it has been understood by a system like Claude, and then it's possible for somebody else to add features to that. If in fact we've stepped up a little bit, taken it out of individual people's minds and made it be understandable by an AI.
Yeah, I think that's definitely
I've
possible.
done that.
Yeah.
I've taken some code that I put together, and it's from various sources. I fed it into one of them. I forget
Yeah.
which one, or maybe multiple, because
They're
I
all
was trying to
set,
figure it
yeah,
out.
they're all
Right?
good.
And I said, I want to add a feature that does this. Give me a code. Give me the code that
Yeah, I
does
mean,
it.
I think that's where we're headed in programming world. You're no longer gonna, just like we don't do assembly language anymore. You're no longer gonna use
What do you
human programmers to do it. You're gonna step up a level and get the concepts into Claude-like programs.
Yeah.
And then be able to do.
I'm looking for somebody who wants a Fortran programmer.
There we go.
I'm real good at that.